Sounds good. Yeah, I'll get us started, and then just want to make sure you guys can see my screen, right? Cool. So yeah, RJ and I are going to talk about the feature store. Why the feature store, how we have built it, and some of the lessons we have learned on that, right? So before we get into some of that, I just want to quickly level set, the ground here, right? Uh, Obviously, many Americans, right, have faced financial stress even before the COVID impacts, right? So even pre-COVID, uh, the American middle class was already under pressure, and with the pandemic, it has further impacted the middle class, right? And coupled that with the advances in technology. So technology has definitely progressed quite a bit, and there are some statistics around that, right? Both of this together, the opportunity of technology and obviously the financial stress, couple that together, sets the foundation for Varo, which was founded to be a different bank, a bank which is for all of us, and a bank which is for financial inclusion, right? So the founders had this clear vision of income inequality, and financial inclusion, and hence Varo was founded. Um, I won't go through this slide in detail, but basically it was launched in 2017. Varo Money was launched on iOS in 2017. Was later launched on Android in 2019. But basically, really started operating as a bank Q3 of 2020, right? Basically, it's just been a year when we are into this bank, right? So and I want to go over at a very high level some of the ML challenges we face at Varo, and then that will set the foundation for the feature store and all of that. So the first and foremost is for any bank, fraud is a big thing, right? And we get a lot of transactions, uh, and we want to try and prevent some of this fraudulent transactions. So the goal is to identify and stop fraudulent transactions, obviously the bad
Sorry,
actors, as early as possible.
sorry, Viral. We're still on the first slide, just in case. I don't know how that
Oh,
looks. So maybe try and exit, unshare, and then try and share again.
oh, I'm so sorry.
No, it's fine. It's fine. We've had some Zoom issues. We're going to ask for a refund. I doubt we'll get it. There, we're on case study 1 now. That's great. Yeah, you're mute. You've gone mute again though, Viral. So we gotta unmute you. So it's in the bottom left-hand corner. There's a little microphone. There we go. But you unshared your screen, unfortunately. There we go.
Can you see my screen? And can
Yes,
you
it's good. You can try and go forward a slide and back just to make sure it's okay.
Okay.
Yeah,
Is it okay?
perfect.
Okay.
Perfect.
Okay. Sorry for all the tech issues here. So yeah, I mean, I was just going over some of the ML challenges we have at Varo, and the first and foremost being fraud. For any kind of bank fraud is very important, and the goal is to identify and stop fraudulent transactions, aka bad actors, as early as we can. Obviously, we want to avoid disruption to all the legitimate transactions, right? So that's one of the use cases. The second one is credit risk modeling. So basically use whatever data we have at our disposal to try and predict credit risk, whether in this case for Varo Believe, which is the card we recently launched, and obviously then the debit card and all financial products in future. The third use case is around obviously recommender systems, whether we want to recommend the right content. Now, whether it's in-app perks, emails, notifications. Again, I'm generalizing that as whatever, any content to the at the right time to the right user. Right. Uh, Additional use case, and again, this is not an exhaustive list of all use cases. We also want to try and predict user financial journey, right? We want to help users move towards a specific goal. So I mean, in a nutshell, basically what we are saying is feature store is the common denominator, right? So there are applications within Varo under risk, under fraud, under lending, under recommender systems, marketing, operations, all of that. The sole denominator of all of that is feature store, and it's extremely important in our case. Um, Obviously, we have internally the feature platform, the model platform, the inference and monitoring platforms. And the idea is once you have this feature store and the rest of the platforms built in, any new use case for machine learning, right? You can quickly build machine learning models and actually then deploy and serve the models, right? Feature store. So that's from the business perspective. From even from ML lifecycle perspective, right? It's very important. Obviously, there's engineers and scientists building and creating the features. We use the same features to do the model training, and then the same features are used for prediction, and then obviously on the monitoring side as well to detect drift and quality issues, right? So we are all aware of feature store, but then there is obviously the modeling store, which when you join it with the labels, you get the modeling store, and for many different applications. And then there is a generalized concept of the prediction store, or now people are calling it the evaluation store. And so I wanted to just put all the stores on one slide here, right? I think I'm going to have RJ go over the journey of the feature store and some of the design considerations here. RJ, do you want to start presenting? Yep. Or do you want me to continue?
You need to unmute yourself.
Hello. Yeah. Can everyone see the slides on I'm on Y feature store?
Yeah.
Okay, cool. Yeah, just making sure. So at Varo, we use Google Meet, so Zoom is some kind of new technology for us. Okay, thanks, Viral, for giving the introduction. And so it's interesting. I mean, one of the things we learned while building our feature store is that it's not so much a technology challenge, it's more of an integration challenge. A lot of the underlying technology is already available for you, but how you define different components, and there are a lot of semantic challenges. And today I wanted to take over that journey of how we started thinking about feature store. So first of all, I mean, we have a 2-day conference on feature store. So we all of know that feature store is an important thing, but why? And I want to quickly go over that. So for example, let's say Viral was talking, one of the use case for us is detecting fraudulent transaction. So for example, if you went Walmart or you just did a shopping on Amazon, we get some transaction data such as amount, store, when the transaction was made. And we constantly have to make decision whether this is a valid transaction, is it legitimate, or it was some hacker who took over your account and trying to make a fraudulent transaction. Now, just getting the transaction data by itself doesn't provide us a lot of information. We need to, in order to decide whether this is legitimate or not, we need to look at some of your historical transactions. For example, we might see, when did you create an account? I mean, was it just recently created or is it new? Because that can be also one of the important features. At this point, I'm just presenting a hypothetical examples, but there is a lot of information that you need to retrieve about the user, about the stores, and like how much is balance the account has. And based on that, you can try to determine whether this is a legitimate transaction or not. So keep in mind, I mean, okay, we are getting this transaction data, but we also pulling this additional data from the feature store. There's another very important example, a reason why we use feature store. So let's say I'm building this model and I found that account age is one of the important variable. And I looked at millions of accounts and ages and when the transaction were made, and this is some kind of distribution I get. And the model, this account age performed very really well in my model training and when I'm doing offline. But when I deployed the model, suddenly the performance started deteriorated. And when we started debugging, we found that the distribution that we got uh, in real time was slightly different from what we were getting in the training side. Now the reason is why. I mean, this is called a training and inference skew. Basically, the distribution of a feature in training is different from the distribution that you get in real time. So when we started debugging this, we identified this is how the sign up flow looks for Varo account. Let's say last week someone went online and signed up for Varo account. The next day the account got activated, and finally you receive a Varo debit card which got activated in 5 days because there's a shipping delays and all that. Now when we were training the model, we used account age based on when the card was activated. So the account age as a term, as a data scientist, was defined based on the card activation date and today. So taking the difference of the two. But when we were in real time, the account age was defined when the actually sign up happened, when the account was created online. And on average, this is a delay of like 5 to 10 days. And this is exactly the difference we see in the account age between the skewness we see. Although this might be seem like just a shift in distribution, but it can have a huge impact on models because, for example, if you are using like XGBoost model, which has a decision boundaries and might say split at 40, whereas now suddenly you have like 50 as a that shift. So there are two reasons you need to use feature store. One is for additional data, to get additional data from the contextual data that you're receiving through transactions or other thing, and to avoid training and inference queue. The another challenge we found was very interesting. We all talk about feature and the word is being used in a very loosely way. What exactly is a feature? Because if you're storing something, you need to define what exactly is the what are we going to store in feature store. And this is the what I wanted to bring up because this is an important piece that often gets overlooked and creates a lot of challenges in later on. So for example, there are various information levels. First is the fact. You have some recorded observations, and this you can absolutely tell whether this is right or not. So for example, when did RJ signed up for Varo account? And we have exactly know that sign up date. But sign up date by itself is not useful. Usually for business or analytics purpose, you will convert that age date into some form of age. So today minus the sign up date, and that becomes the age of my account, or it can be either in days, years, whatever the business unit makes sense. Now, when you're building models, often you also apply another level of transformation where you will take this account age, which is in this case in numeric, but also you can convert that into binary. For example, I can say, oh, people who have less than 30 days in account age can be an important variable, or less than 90 days. These can be treated as news customer, and the model can try to learn certain behavior about that. In another model, you might say, oh, I just want to do a logarithmic age because I see a high skew in that behavior. So you might try to normalize by taking log of age. So there are many different variations, and this is kind of explodes. You have one fact, but after vector transformations, you might have hundreds and thousands of features. Now, the interesting thing is, when you talk to different domains within a business, what is feature is different thing. If I go and talk to a business unit, they might say the fact as a feature, or they might even call data transformation step as a feature. And if you talk to a machine learning engineer, they might call feature as what you get after vector transformations. And there's a huge implication about at what level do you store the data. So you can store data at a fact, or at fact level, or at a vector transformation. I like to think of this as a continuum, and fact and vector transformations are two extreme end of it. So if you're storing things at a fact level, the advantage you get is the information is highly reusable across a lot of different models. But then the downside is the computation. If you're storing things at a fact level, all the models, for example, might have to convert account sign update into some form of age. And that you have to do every time you have to generate an inference. So there's more computation that needs to be done at a fact if you are building a fact store, or versus if you're storing things at a vector transformation level. Interestingly, I mean, if you look, there's no consensus within the industry. For example, Netflix calls themselves at building a fact store because they really storing the facts and not the transformations. Whereas a lot of other companies like Google, Facebook, they call themselves feature stores because they are trying to store transform values. I will speed up a little bit. So once we had some of these clarities, we started thinking about what are the principles on which we want to build our feature store. The most important for us was the reusability. So we wanted to move more towards facts, like storing facts, or even data transformations, not the vector transformations. So we focus on reusability of the contents that are stored in facts feature store. The other important thing was consistency over accuracy, because as you saw in that training inference skew, the main objective of feature store is to remove those kind of skew. Feature stores are not designed to do analytics and but more for like addressing the skewness issue. So we don't care how you calculate account age, but we want to make sure that it's consistent between your training and your when you're making the inference. The third, which is related to reusability, was we wanted to make it very easy to discover features. Not only features, but how these features are computed. What is the metadata? Are these features has any kind of PII issue? And really create those linkages where we can see one feature, how this feature is being used in different models, and what are the features a particular model is using. So create complete graph between features and models and their original data sources. And the lastly, this was more a learning based on our previous iteration of feature store. We wanted to keep our features independent. Now, again, I'm using features as a very generic word over here, but when I'm calling features, mostly it's focusing on data, facts, and vector transform on data transformations. So another learning we had was like keeping features independent. So that makes your life easy when you're doing backfilling. So you don't create a chains of backfills. And this is our current implementation of feature store at Varo. So we have two separate pipelines. One pipeline for generating our batch features, features that we don't really need to be updated on a daily basis. For example, age, account age, or the balance in an account. And then, sorry, balance is actually a real-time feature because we want to know in real time whether the person has a how much balance it has. So that is an example of a real-time feature. So for real-time features, what we do is we get Kafka events. We have a feature service which listens to various lot of Kafka events, and based on that, it does the required transformation and stores the latest value in our feature store. For batch processing, we have again Kafka events coming in. And these Kafka events on a daily basis gets processed, cleaned up, and then we use Hadoop and Presto SQL engine to transform these data into like a massage data, cleaned up data, and store on a daily basis these values in our offline in our data lake. And from data lake, the latest updated values are pushed to our online system through Kafka again. But one of the interesting thing is like we also have this change detection system on our online features too, which populates any kind of online real-time features that we are building back to in our offline data store. That way we are kind of building a historical data for our features as well. I mean, for real-time features. Now, this system is definitely not the last system we will be building. I mean, there is a lot of issues we are already observing, and we see what are the future systems we need to build. So one of the challenges we have is now we have multiple systems. We have one system to build a batch of features and another system for building real-time features. And managing two different systems is always a lot of hassle. The another is we have duplicate code. When we backfill real-time features, we have to use our Hadoop ecosystem. So write the whole feature engineering code back in SQL or PySpark, and whereas in real time we are using Kotlin. So you're duplicating your code across two systems. There are some interesting solutions for addressing these, and there is, I mean, for people who are interested how to solve this issue, there's a whole notion of delta architecture, which is really leveraging Spark ecosystem to handle both real-time and batch features and avoid this duplicate code. There's another challenge, which is like always open-ended, which is a monitoring system. How do you build a monitoring system? You want to detect those kind of drifts that I was talking about earlier, where there's an inference skew, or even the features over time can change, or there can be pipeline issues because of which you are getting missing values. So those are the areas where we have to work in going ahead. So lastly, I mean, we are still hiring. I mean, anyone who is interested, we are happy to talk, and definitely the team is growing, and there's a lot of areas. I mean, as a machine learning team, we are spread across both building the platform and also working on applications. For example, we are using building a chatbot. We are automating how we are computing these features. There are explanation issues. So if you're interested, definitely contact us. Any questions?